Well, hi, good morning, and thank you so much for joining me in my shop today. And today is a beautiful, sunny but cool day here. Fantastic sunshine, actually. September 20th is the date. At any moment now, I'm pretty sure my coffee alarm is going to go off. And if I could only find it, I would show it to you. So I'm going to start this video with my coffee alarm, which I've set somewhere. Well, maybe when it goes off. I think it's going to go off any moment. Okay, so what are we going to do with this radio? So yesterday I replaced a couple of capacitors and then spent quite a bit of time listening to the radio to get a good judgment of its operation. The AM side seems to be very good. Shortwave side, hard to say actually from yesterday's test because the sun is angry these days, and plus that was the middle of the morning. Not really the best time to be listening to shortwave. So today I'm going to run through the alignment process. I think the radio's in pretty good shape as it is, but I want to do the final tune-up on it. And maybe find that coffee alarm. Where did it go? How come it's not alarming? Okay, let's carry on with the coffee alarm theme. Here it is. So this I bought at a yard sale. I couldn't resist. It was like $1. I liked it because it looked like it has vacuum tubes in it, and it's actually a clock. You can read the time there. What's it say there? 9:14, and the correct time actually is. Wait, see it up there? Oh, what's going on? Oh, I know what's going on. I got too many lights on here. 9:19. Well, come on, alarm. You ring every morning right now. I'm just going to set it here. The thing about this clock is you can't read the numbers on it. Can you read the time? Can you read the time? You can only read the numbers if it's got some kind of a black sheet behind it, or I'm sorry, white sheet or something like that. I think it's going to go off any moment, and then I'm going to go have some coffee. When that happens. Yeah, why do I have that? So I bought that at a yard sale, put batteries in it, clock came on. I'll show you again. Underneath it are two buttons. One says mode and one says set. And you know what? I have not been able to figure these out. I got enough. I got the time on it. I don't know how the alarm came on. I don't know how to set it or turn it off. That's why it's become my coffee alarm. Okay, just trying to make hay out of it. So, let's see. The recommendation in the instructions is to use the plate to cathode voltage on the output tube to monitor the output of the radio. And I'm not going to do that. Instead, I'm going to use this very high impedance meter over here, this guy. And we're going to watch the AVC voltage. It's not necessarily the best way to do it. But I think really what some of these instructions are reacting to is the idea that repair guys had lousy equipment. So they had a crap meter that they wanted to use to do their tests. Okay, maybe not as crappy as that, but something crappy. And you can't go measuring certain voltages with crappy meters, or you disturb the voltages that you're measuring and throw the radio off. So if you had a low impedance meter, you try to measure the AVC voltage, you might be disturbing the radio's operation too much. So I'll do a little experiment just to make sure that the meter I'm using isn't throwing the radio off. And that's simply connecting it and disconnecting it to see what happens to the radio. And I'm guessing what will happen is nothing. The radio will perform just fine, and we can carry on. If not, then I can always revert to what they're suggesting in the instructions, which I have done with previous radios, but I'm a little uncomfortable because you're bringing the B plus voltage right out onto your bench. I'm not so sure that's a great idea. Okay, so we're going to tip this guy up here. Come on, coffee alarm, where are you? I thought it was 9:17 it rang every morning. It's 9:22. I don't get it. My coffee alarm is failing. What, does that mean I can't have any coffee? Yikes. Okay. So a good place to pick up the AVC voltage is on the input side of the volume control, which is right down here. Volume control. Got the 3 terminals. Center one is where the sound is heading back to the amplifier, and then the input side is one end, and the output side is, I better not say output, the grounded side, usually a grounded side. So which is which? So just thinking about it, yeah, that's enough thinking about it. We turn it up, we bring in more and more, so this will be the input side here. This will be the signal grounded side. Input side. Well, we'll know if I'm right when I hook up the voltmeter to it. I'm absolutely not. I'm not actually sure. See, this is what happens when you don't have enough coffee, because your coffee alarm is failing to work. This is the input side here. Okay, so we're going to go on the other side of this orange capacitor to here. I'm going to pick up the AVC voltage there. Now, a lot of instructions say, oh, wait a minute, don't run your signal generator so high that there's an AVC voltage. And I think the primary reason for this is it can become more confusing when the okay, so we'll connect this when the time comes. So I can do the little experiment. We'll just put this. Now, should we do this to the chassis or to B minus, or am I not remembering this radio? I got too many radios in my head now. So I can't remember how B minus is handled in this radio. So I'm looking for some big capacitors. Big guy. Looks like this is a spot right here, right on the chassis. Okay. You know what? Lack of coffee is really causing problems here. I'm I'm just a little. Yeah, we didn't want to hook that up yet. Come on, man. Oh my gosh. That's a crazy morning here. Look at the problems that are occurring from it. Okay, so we're going to put that there. We'll try that. Okay. This is crazy. I'm crazy this morning. Why am I so crazy this morning? I don't know. And no coffee alarm. Well, that's really disappointing after explaining it and then it didn't go off. Huh. How come? Oh boy. Okay. So that's the meter connection. Now we need a signal generator connection here. I'm going to have to read the instructions too, because the first connection is probably to a grid here. Well, you know, regardless of the lack of coffee alarm, I'm going to go and have a little bit of coffee and then come back. Maybe I'll be maybe things will be a little more organized. What? My coffee alarm's going off. 9:45. Oh, okay. Yeah, 9:43 is what it actually says on there. Okay, I got the time wrong. That's why it wasn't ringing. There we go. And if I could set that time or turn that alarm off, I would do it. But I can't. But you know what? It's forcing me to go have some coffee. So let's start up this meter because it needs time to warm up. Got the signal generator running. It's at just under 470. That's the target frequency, 470. I've got the equipment tied to the chassis as instructed. So the grounds of of the meter and the signal generator, just on the chassis here. Just in behind there's a capacitor I've connected to the grid of the first tube. That's the 6A8. It's sitting here. This is the tube that acted a little weird yesterday for reasons I don't know for sure. Some kind of very serious make and break kind of intermittent thing going on there. Maybe. So this will be the voltmeter lead, and I will connect to this red clip lead, which is going around to the right near the volume control I showed you earlier. So that'll supply. I don't want to hook anything up. I have the radio operating, and then hook things up and see that it does not disturb the radio. I also have my tools lined up here. This is a nice stiff, very thick, stiff, basically flathead screwdriver for making alignment adjustments, and if I need it, I have a metal screwdriver ready to go. Everything's ready to go. Okay, but the alarm is saying go have a coffee, so I'm going to go a few more sips and then we'll start here. Okay, let's start up the radio here. Switch is off. Here we go. So the idea here is get the radio operating, like a radio, tune something in, even if it's just noise, some kind of signal, hopefully a radio station on broadcast band. Still got it hooked up to my outdoor antenna here for what good that might be. And okay, all is normal. Let's put it on full. I've now hooked the radio directly to Niagara Falls here. There we go. We're on the broadcast band. It's a little interesting. The station appears to be in a different location. I think it was picking it up here. Why would that be? Okay, well, let's look into this. I do have this clip lead. Wow. Don't overpay for the same service. No upfront fees and no hidden costs. It's gonna make you wonder. It works better with my hand here. Better than my outdoor antenna. I am better. My outdoor antenna. Wow. Let me disconnect it. It's doing absolutely nothing. Oh my gosh. That's kind of weird. So this is the ground lead. Well, this goes to the shield part of the coax cable that's feeding into here, and this is the center conductor. Holy smokes! There's a lot of things here I can't explain. There's more antenna juice in the ground. Well, that's an odd thing, okay? Lots of odd things here. Let's leave this out of the picture. Oh, I don't get it. I have to have the ground connected to the ground. And then my hand works good.
Learn how you can apply to be a JCare affiliate school today. Visit jcare.com/school. I think the neighbor's been watching me when I'm in the kitchen. I'm serious. She watches me in the window.
So I have the antenna ground connected to the ground terminal, the antenna ground terminal on the back.
So you're telling me when I was in my boxers the other day, she was only checking out the cabin.
And if I remove it, noise but no signal. I take the center conductor, stick it on the ground, stick it on the antenna side. And if I put the ground back on, just on the antenna terminals here at the back. Everybody's getting close to this. Well, clearly, when you're operating this radio, you need to stick your hand in the back just about here and make it work good. Well, that's all weird stuff. So we have the signal. How am I gonna prove anything here? Let's turn it back up. Looking at the signal generator should make it go quiet. Well, there's the signal generator signal right there. That's fine. I think that's fine. But what we really want to find out is, looking up this voltmeter, does it throw it off? So here's the ABC connection. Nothing whatsoever. This is a very high input impedance meter, 125 mega ohms. Okay, so we can hook that up. Meter's going upscale because it's set for negative, so a negative voltage goes upscale. And right now it's on the 10 volt scale. And we tune some stations in and out and see it move. Good. Make it a little more sensitive here. Okay, there we are. Everything is good to go. Let's put the signal first. Close the capacitor. That's where it suggested this be done. Yikes. Let's turn this down. It's pretty high. Can we go lower yet? So I'm going to disconnect the antenna here because it didn't do a darn thing. Tune the radio a little bit. Yeah, let's get it in a quiet spot. Right there, right at the end of the run. Okay. First I'm going to tune the signal generator through some frequencies, and I'm going to watch the meter and see when the meter's at its highest point, what frequency is going into the radio here. Right where it was actually. So that says 468 here. In my setup you can add 1 or 2 to this. It's at 470. So can we make this any better? Boy, I doubt it. I'm pretty sure I tuned it up properly the last time, but let's check because we're right here. We'll just go through the different watching the meter now. I hear a trigger on this. With these screws, and the slug would be the same. If you're pushing hard with the tool, you can move the screw, and when you take the screwdriver away, the screw will relax back, and you get a variation. So you don't want to push too hard with these. That's right on the money. This here one. And you've got a tidbit higher out of that. And the last one. Okay, so the IF is tuned up very sharply on 470 as it's supposed to be. So that's good. Now it's the rest of the alignment here that is I did not do last time, pretty sure, because I didn't have the dial face and all that kind of stuff. So what we will do next is set up for the HF alignment, and I think it's all done on the top. I don't think there's anything. It's just, I just do so many radios. I got so much stuff bumping around in my head now. I can't remember one from the other. But I think everything's on top. So I'm going to stop for a bit. We'll get set up for that.
Well, let's see what Scripture says. Now, what's the next verse you've got down there? And cried again with a loud voice, yielded up the ghost, yielded up the ghost.
So the amazing thing about this radio is it's receiving this signal. Yes, it's a very, very powerful signal at 9.330. Here in North America, it's very, very powerful. And for an antenna, all it has is the connection to that signal generator, and that should be the worst antenna in the world. And yet there it is, picking this up really well. Now if you look at the SDR, I'm going to turn this radio down. We're going to listen to the SDR for a moment. Okay, so we can see that I've got the SDR set to 9330. And you can see the signal right here. Now the SDR is trying to pick it up on this little loop here. So I may have to help it out. Let's listen to what the SDR can hear. As compared to...
Because immortality, by definition, is exactly...
That's blowing me away. Neither radio has a decent antenna connected to it. Or am I full of crap here? No, I am not full of crap. This is the outdoor antenna connection here. Not connected to anything. Well, that's interesting. Okay, that's really interesting. This radio is working really well. Now, 9.33, where is it on the dial? Let's take a look. And I'm very likely to get this wrong because that's what I do. I look at the wrong scale all the time on these radios. So, okay. Outside scale is the AM band. In kilohertz, inside scale is the shortwave band in megahertz. So there's 18, 16, 14, and right now we have it tuned to 9. That's 11. This must be 10 here. So that'd be 9.5. It's individually marked 9.4 instead of 9.3. So I mean that's like the width of the needle in accuracy. That's really very, very good. So that's where we're starting from. Now, what do I need to do now? I need to put this back here. Something like that. Maybe swing it over like this. Okay, so you can see what I'm going to be doing. Now, we're gonna use the 9. We're gonna use this station. So, in order, so what do I want to do? So I'm gonna want to tune this dial to exactly 9.330. Now, for crying out loud, it's just about exactly on it. Now I'm looking at it with a little less parallax. Wow, it's really, really close. Did I bump it? What happened? Maybe it faded out? Maybe I bumped it? I moved this antenna a little. Well, it seems to have gone away. Okay, so we won't do what I was going to do. We'll do what it says in the book. Better idea to follow the book anyway. That's kind of funny. It could just go from being quite strong to fading right out like that. So we want to do this at 18 megacycles. So again, the SDR is going to be very helpful for this. Let me get this up to around 18 here. Okay, there's the shortwave band right there. This thing here is probably coming out of the radio. That's not what I think we're interested in. So lots of weird stuff go by on the SDR. till we get up around 18. Now let me get right down here. Again, we're talking about the width of the pointer here. So now that's on 18, and we would expect the local oscillator to be 470 kilohertz above that. So we are tuned to 18. 18's way up here. 18's not in the broadcast band. But it seems to be marked as if it is on here, on the radio. It's very hard to see, but they have a little sort of indications as to where the different bands are. Oh well, okay. So we should go 18 plus 470. So 18 470 should be a local oscillator right up in here. Did I not put it on shortwave? Yeah, of course I did. Yeah, of course I did. Where's that local oscillator? Let's move this around and see if it goes flying by. That's probably it there. Okay, so now the radio is tuned to about 18.4, and this is in the wrong place completely. So we're tuned to 18.4 up here. And if you subtract 470, I think you're going to end up here. Is that true? So we go 18. So there's an issue with these radios. These shortwave radios with the bands that run from very low, say around 6 megahertz, all the way up to 18, sometimes much higher, 22, stuff like that. Those radios, these radios, they have a big problem up in the higher ends. It's actually all the way through, but it's really apparent up at the higher end of the band, where the you're mixing the local oscillator with the signal you desire to get the 470 difference that will go through the IF. Well, you can stick the local oscillator on this side and get the 470, and it'll go through the IF. So a couple things can happen here. If you're tuned, I'm not going to go into this in detail here, but you can end up picking up stations that are almost a megacycle away from where you're tuned, based on this weakness in the radio. It's called an image. You can look up image rejection and read about it rather than have me try to explain it. It's not too complicated. For me, it gets a little complicated when you actually work on the radio itself. I often have to stop and think hard about it. So that's what I'm going to do right now. I'm going to stop and think hard about this. So the suggestion here I'm making is the radio is aligned incorrectly. It's not very likely. It's more likely I'm wrong. That's where my head is right now. So I'm going to go away. They have instructions here on how to avoid this problem. Here's the instructions here. But I have the SDR, which is extremely helpful in this case. What I have to do is figure out, is the local oscillator supposed to be below the tuned frequency or above? Which way do they have it in this radio? It varies from radio to radio. Even band to band it can change. There's only 2 bands in this radio. Okay, yeah, I'm going to stop and study this and try to get my head around it, so I do the right thing. Okay, let's see if I can think my way through this. I find this so confusing, trying to understand what to do here exactly to make sure I get it correct. So what it says here in the instructions is to tighten the trimmer right up so you have it at maximum capacity, and then begin to loosen off the trimmer. You're loosening off the trimmer is reducing the capacity. So reducing the capacitance of the tuned circuit. Reducing the capacitance of the tuned circuit will bring the resonant frequency down. So what you're doing is you're moving the local oscillator down from a high point, because you've cranked the thing tight, you moved it way up here. Now you're reducing the capacitance, it's coming down. As it comes down, so here's the signal generator signal. And the local oscillator is starting way up here. and in between here is more than the IF. Let's say, I don't know, 600 kilohertz here. So you're turning the capacitor and you're bringing this down, down, down. When you get to the 470 point, you'll have the difference frequency. You'll go through the IF, you'll hear it come out the radio. If you keep adjusting the trimmer as it suggests, you go down, 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 down. When you get down here, once again, you'll hear the signal because there'll be 470 here in between. And what it's saying is, don't use this one, use that one. And I believe what that's telling me is the local oscillator should be below the target, which is what I need to know so I can make best use of the SDR up here. And that appears to be the case right now. And it would be very surprising if it wasn't, because that would mean either the factory booped it up, which is very, very unlikely, or somebody monkeyed with it, and I think that's very unlikely in the case of this radio too. So that being the case, we'll now look at the SDR again, and we'll figure out what frequency we're tuned to. So it's 18 on the dial. 18 on the dial. Okay, this is where I'm going to get confused. So remove the local oscillator. See, even though it says 18, the local oscillator in the radio is way up here. This radio is really tuning up around 19300, something like that. How about 19418? So that makes the local oscillators way, way, way off here. Way off. Is that even believable? Well, let's try adjusting it and we'll see what happens here. So to tune 18, this is going to be really tricky. To tune 18, the local oscillator should be below by 470. So 18 minus 500 is 17,500 plus 30, 17,530 is where this should be right now. So we'll head that direction. Should get another. So there's the lower one. Sounds exactly the same on the radio. You couldn't tell one from the other. But this should really say 17. What did I say? Oh, I forgot the number. 17 something 30. And why did the radio just jump just now? Well, what happened there? Because I just looked up at the SDR and I could see the on the waterfall an increase in local oscillator strength, or so it looked. Oh my gosh, I'm so confused about this stuff. Just turn. I mean, I'll get it, but on the way, wow, it's so painful for me. I don't know. There's something about this that I have really a hard time figuring stuff out. Well, why don't we do this? So we're at 18.4, and the local oscillator is sitting above. We need to push that local oscillator way down to way down. Can we even get it down? Okay, so I'm going to try adjusting the screw here. I think we'll try with this. Okay, which one's which? Okay, so this one has to be the local oscillator here. Okay, watching the SDR, I'm going to try to move the local oscillator. You know what? This is not stiff enough. I have to use a screwdriver. Great big honking screwdriver. Okay, so you can hear the effect of the... I can't use this. Can I use a metal screwdriver in this case? Let's try a little puny aluminum one. No. Is it my hand? No, it's the screwdriver shank getting right in there. What was that big pop there? Uh, a stiff tool to try to turn that screw. Let's try again with this. Maybe it just needs to be broken free or loosened up. Tell me, even this plastic thing? Huh. It's not my hand. Even this plastic piece? I guarantee you, I've got all kinds of radio repair books, and not one of them talks about a plastic tool affecting the radio. Not much of an effect. Okay, turn that baby. Oh, I'm gonna wreck this. It's stuck solid. So let's use a metal screwdriver to break it free. Assume it's jammed here. Doesn't that There we are. Oh, it's hard to get the screwdriver in. So, should it? What's going on here? How come you're making so much noise? Must be, Oh wow, this is really stuck. Okay, we gotta think a little bit now. How hard should I push on this thing? This is just stuck solid. Oh! That's too bad. That's not adjustable. I don't think I can adjust that without something terrible happening. Okay, how bad is it? Let's take that approach. Since it looks like it can't be adjusted without an unnecessary risk. The risk is you end up with nothing. Like right now the radio's working. Why would we want to end up with nothing? So if we go back again.
Contradicts the word of Yah. It's a very real danger, and the closer we get to the end, the more prevalent will be the danger.
So it's about 9.45, 9.5, somewhere around there. Again, we're using a signal generator. The lead is the antenna. Wow. Well, what we'll do, we'll skip the local oscillator adjustment because it's too much risk. I think, my assessment, the risk value, there's little value in it. Especially you get up at this part of the band, look at how tight it is. I mean, you know, a needle width is a huge amount. So you're just going to go up here and fish around for stations. You're not going to, and you know what, you're not even going to go up here anyway. You're going to be tuning mostly in this range where it is now, and later at night, down here, especially down here, later at night. During the day, maybe up in this area. Each band is marked out. Usually they've written a few cities right where the band is. A band there, band there, band there, band there. So you get into those areas looking for something, and it's not far off. Here, it's way off up here. That's interesting too. Way off up here, not so far off down here. But with a radio like this, I mean, you don't look in a book and find a frequency and then try to dial it in. That's not happening. So I think I've justified doing nothing, but the last step is, it's a video of me justifying doing nothing. The last step will be Well, that's all there is. That's all there is for here. Now we go back. We go back to the AM band. And we do 7A, 4A, 7, 7. Oh, we're doing these kinds which are buried down in the chassis. 7, 7A, and 4A, which is this one here. I've already tried turning this one and couldn't do it. So let's go do that stuff. So we got to go to the broadcast band. We're going to dial up 1500. Okay, we're on 1500. And what are we doing there? 7A and 4A. 7A is the outboard one here. 4A is on top. 7A first, then 4A. 7A is probably an oscillator. They don't say. So 1500. So 1500. Okay, let's go 1500. Hello, 1500. Now you may not be able to read those numbers. 1517. It's very, very close. So let me just make sure this dial is right on the money here. Just up a wee bit. Right there. Right on the money. It's ever so slightly high. Yeah, did it just get louder there? Was that my imagination, or? Could be my imagination. So, what's to adjust? We don't want to adjust the oscillator. It's right on. So the other one would be the antenna adjustment. And this is a little bit bogus without the actual antenna connected. Oh, that's my metal screwdriver effect. This is the other screw on the capacitor. It could be frozen too. Oh yeah, you know what? I think it is. I can't move it. Well, considering that the alignment's really good here, perhaps this radio is just properly aligned as it is. Let's go check the frequency down here. We're down to 600. This is most of the tuning of the radio will be done down here anyway. Is where the stations are. So we'll go to 600. And we'll say, okay, is that really 600? I'll dial this to 600 now. No, I won't. There I will. That's 300. That's half of it. So that was a harmonic coming from the signal generator. Going through the IF. 600 coming. Getting quite the ABC voltage here. Okay, the actual frequency when your dial says 600, we're actually tuning 620. Now, is that worth changing? Well, maybe a little bit. Let's see if I can turn that adjuster. So this would be the adjustment here. I put the metal. Ooh. I'm adjusting and nothing's happening. And you won't find that in any of the books either. And when you turn the adjustment, if nothing happens, this is what you do next. You won't find that part. Why would that not do anything? 7A. 7A. Well, you know, it's supposed to be done at 1500. Could be the sensitivity of this adjustment is next to nothing at the low end of the band where we are now. So let's go wild with it. I'll make sure I can return it. It's one full turn. 2 full turns. Just feels like nothing's happening at all. Okay, so I'm looking at the meter. The meter is going down. This is many, many, many turns in it. Wow. Let's keep going. Okay, meter's gone down. So let's tune the radio again. Okay, so that's pretty much exactly the same. We're actually listening to 620. I'm not getting anywhere with it. How can this be so far off? As I turn this, slowly this meter's going down. Which means this tuning is going off. I think it's going this way. We really want this pointer to head to be maxing this signal at 620. It's going the wrong way. Let's tighten this even further and make sure this is the case. I don't get it. How many turns can you have in this thing? Is this just a... Oh, it's tightening up. Tightening up. So we hit the end of the road. This isn't moving at all. We're not getting anywhere. So if I put 600, let's do it this way. This makes a little more sense. If you wanted to listen to 600, it's kind of backwards. This is where you'll find it. 20 below. So if you wanted to listen to 590, which is the strong AM station, you would find it right there. Okay, let me take off the signal generator. I'll stick on my outdoor antenna for whatever it's worth. And we should hear that station. Yeah, right on. Unfortunately, there's a noise signal in there with it, that chirpy sound. Not much I can do about that. There is another adjustment suggested here. Down at 580, we do number 7. Well, that's roughly where we are. We're listening to a station. Number 7 is the next one over. Okay, let's see if this will... Or you know what? This could be the lower end capacitor. This, yeah, you know what? I could have. That's definitely changing the oscillator. Okay, so should have read the instructions better. So we want this signal to be up at 590. So I'm going to move this, and then I'm going to adjust it with my screwdriver. You cannot see because it's hidden from view. There. Bring it back. Bring it back. So now we'll set this right on 590. Now tuned for maximum on the meter over there. This is where the AVC can trick you up a little bit. Okay, so now we're getting 590 at 590. Very good. That may have adjusted the upper end just a wee bit. Probably not. We could go back and do the 1500 and try. Let's try it. 1500. So the hint here that I missed is this. When you look at the capacitor, you see the two sides are the same size. They aren't particularly different. In some radios, one of these will be much smaller than the other. The smaller one is the local oscillator. When they're not, and the smaller one does away with an additional tuning capacitor. But this is not a smaller one. It's the same size. So there needs to be two trimmer capacitors. One in parallel with this capacitor and one in series with it. And that's what's going on. I'm going to show you this too. With these two adjustments that are way down there, down here. These two adjustments here. One is doing the high end of the oscillator, and the other one's doing the low end. Okay, now we want to get this to show 1500 here, or to react to 1500. So we're sending out. We have to hook up the signal generator to make it work. There we go. Okay, now let's get this tuned right on the money here. Okay, 0 parallax. Whoops. That's right on the 1500 mark. Doesn't look that way in the camera, but that's a parallax error. Looks like we're tuning in 1590. So we want to bring that down. Okay. Turn this thing a mile. Okay, that was many revolutions of that screw. Now we'll see where we're going here. 1570. Got a long ways to go. We'll set this to 1550 and we go by it, we will hear it. There it goes. Keep going. Ooh! Did you hear that ding sound? I don't know what that was. I'm pretty close now. Can we go a little further? We can. Okay, we're going to get a 1500 here. Okay. There we go. 1500, some kind of interference here. Now we'll go back and see what happened to 590. 590 is probably not where it was. Turn that there. We have no antenna hooked up. Why don't we just put it on the antenna for a moment and see if in fact it's still there. Excellent. 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 Okay, I think I've monkeyed with this thing enough. I don't think there's... that's good. That's good. It's very good. Okay, one more experiment. And then we might be done here. Now, in some of the previous videos I used a large loop antenna that's just behind me here in my shop, but I brought in this small commercial loop antenna, which I think is ideal for these radios, because it can sit right on top of the cabinet if you like, but let's see how well it works. It's a smaller loop, and it's right up here on my bench. The leads I'm using are very short, so it's right up here, not exactly where you might want it. Well, let's leave this on, because I think it's still connected. Okay, here we go.
Well, Jeff Bond, thanks so much for time out, man. Really appreciate all the
Okay.
confidence you give the JSON Plus
Tune it a bit.
around that New Hampshire team and system, and the best of luck to your kids in the upcoming football season.
Now this antenna is tuned like all loop antennas. Here's the tuning knob.
We're cheering for a World Series. Unbelievable.
It's also directional.
That's baseball, man.
Clip lead just popped off here. And it fell over. the directional antennas like this. The idea is not so much, well, it could be you want to aim them at the station you're receiving, but that doesn't boost very well. What this has is a very deep null. So there's a direction from the antenna where signals will not be heard, and you can use that to try to get rid of interference, like what we're listening to. That chirpy higher sound is also a clicking sound in there. So we can kind of get rid of the chirpy one a little bit. There, we got rid of the station, so you know it's at 90 degrees. So that's maximum station there. Let's go see if we can get this French station. See the antenna? What do you say we compare it to my big loop? So that's what this guy can do, but he's up on my bench, remember. It's a bad place for it. We'll switch to my big loop that's behind me here. Okay, gotta tune it in. And aim it. It's aimed completely wrong.
Aux États-Unis, les travailleurs de l'automobile continuent de faire la grève contre Ford, ainsi que dans les usines de General Motors et de Stellantis.
Very good. And unfortunately, all that staticky sound, all that stuff is just the radio. It's not the radio's fault at all. It's the environment that we're operating in. That's it for this radio. It's all fixed up. It's ready to go. The loop antenna here will perform much better in other locations than here in my shop. Much better. And of course, in the evening, there'll be lots of different radio stations to pick up. And the only thing is, you got to keep tuning the antenna to match the tuning of the radio. You can't go too far. You know, maybe 100 numbers up and down, a short range, before you need to retune the antenna, and perhaps even re-aim it, depending upon what you're up to. So thanks a lot for watching the series. This radio will be on its way home. I think the owner is anxious to get it. He's got his cabinet all fixed up. It's going to look fantastic. The front of this is going to look beautiful. Great. I just have to put the glass back on it. That's all. That's no big deal. Okay. Thanks a lot for watching the whole series. And I've got the next radio. Next radio is waiting. It's waiting. Thanks a lot. See ya.